Hi students, today we're going to be continuing 2.5, which is on proofs and how to write two-column proofs. But before we start, we're going to need to kind of review some very important properties. So first, let's start off with the properties of segment congruence. Segment congruence is reflexive, symmetric, and transitive properties. The reflexive property states that for any segment AB, line segment AB is congruent to line segment AB. So if you have the same line, it's congruent to itself, right? So that's what the reflexive property states. The symmetric property states that if line segment AB is congruent to line segment CD, then line segment CD is congruent to line segment AB. Okay, so basically if you flip the two, then it's the same thing, right? It means the same thing. So that's what the symmetric property of segment congruence states. The transitive property of segment congruence is kind of like when we talked about law of syllogism. It's kind of similar, right? But the transitive property is more geared towards your actual measurements. So whether that be angle measurements or segment measurements, it's the same thing, but in these terms. So if we look at the transitive property, if line segment AB is congruent to line segment CD, and line segment CD is congruent to line segment EF, then you can conclude that line segment AB is congruent to line segment EF. Okay, so these are all going to be your properties of segment congruence. Now, you can also use this to prove angle congruence. So you've got your three properties. They're the same thing, except this time we're dealing with angles. So for reflexive property, for any angle A, the angle A is congruent to angle A. It's congruent to itself, right? For the symmetric property, if angle A is congruent to angle B, then angle B is congruent to angle A. For the transitive property, if angle A is congruent to angle B and angle B is congruent to angle C, then angle A is congruent to angle C. All right, so we're going to go ahead and continue. Okay, so we are going to go ahead and continue reviewing how to write a two-column proof. So in a proof, you're making one statement at a time until you reach a conclusion. Because you make statements based on facts, you are using deductive reasoning. Now, we've already talked about the difference of inductive and deductive reasoning. The reason that proofs are deductive is because you're starting with something that is given. You're starting with something that is known. You're starting with a fact, right? So, and then you're basing your conclusion off of that fact. So just to kind of dissect how these two-column proofs look, you're always going to start with what's given. Your first statement is going to be what's given. So if you're told that you're given angle 1 is congruent to angle 2, right, based off of this diagram, and you're trying to then prove that that angle 2 is congruent to angle 1. All right, so you're going to start with the given, which is angle 1 is congruent to angle 2. That's given. Now, if you're dealing with, if you're trying to prove that angle 2 is congruent to angle 1, we know that eventually we're going to be using the symmetric property because we are switching the two. But first, you have to talk about the measurements, because the symmetric property of equality states that the measurements of those two angles are congruent, or are equal, I'm sorry. So before you can go there, you would have to say the measurement of angle 1 is congruent to the measurement of angle 2. So you'd have to ask yourself, okay, so why was I able to say that? What reason led me to be able to say that? And that would just be the definition of congruent angles. So by definition, if you have two angles are congruent, then we know that their measurements are congruent. So that's just the definition of congruent angles. From there, then you can say if the measurement of angle 1 is equal to the measurement of angle 2, then you can say that the measurement of angle 2 is equal to the measurement of angle 1 based off of the symmetric property of equality, okay? And then from there, we know that if the measurements are equal, then we can go back to saying that the angles are congruent, right? So if measurement of angle 2 is equal to the measurement of angle 1, then we can conclude that angle 2 is congruent to angle 1 based off of the definition of congruent angles. So your last statement is going to always include what you're trying to prove. Okay. All right, so let's do some practice. Looking at question 1, it says line K and line L bisect each other at point M, and BM is congruent to CM. All right, so before we do that, it kind of helps to show the congruence on the diagram. So we know, we're told that CM is congruent to BM, right? And we're also told that line K and line L bisect each other, right? So then, if they bisect each other, then we can state that that we know that AM and MB are also congruent, right? So if they're congruent, and we know that this is the same as this, then we know that all of these segments are equal, right? Okay, so we're trying to prove that AB is equal to AM plus DM. So AM and DM. We're trying to prove that these two, the sum of those two, is equal to segment AB. All right, so we're going to start off with what is given. We're told that BM is congruent to CM, but we're also told that line K and L bisect each other at point M. So they did not include that. That needs to also be included in the given. All right. So then they went on to say that CM is congruent, that the that line segment CM is congruent to line segment DM. All right. So if CM is congruent to DM, we can state that based off of the definition of a segment bisector. Then they go on to state that BM, that segment BM, is congruent to segment DM. So if we know that BM is congruent to CM and CM is congruent to DM, and then we're saying therefore BM is congruent to DM, then what did we just use? We just used the transitive property of segment congruence, but you don't need to write that part. You could just do transitive property. Okay, and then from there, we're trying to we're basically trying to go from congruence statements to equality statements, right? So then we would need to change that congruence statement to an equality statement. So if line segment BM is congruent to line segment DM, therefore BM is equal, measurement of BM is equal to the measurement of DM. And this is just by the definition of congruent segments. Okay. Next, we're told that we're using the segment addition postulate. So, all right, so we're given all of the information that we need, so then we can conclude, or we can say that the measurement of AB is equal to the measurement of AM plus BM. And the reason I chose that one is because I am trying to prove something with the line AB, right? So line AB, and if we're using the segment addition postulate, line AB is the same as AM plus BM, right? So that's the segment addition postulate. Now, the next part is easy. All I then have to do, if I've already proven that DM is equal, the measurement of BM is equal to the measurement of DM, now all I have to do is substitute DM into BM, and so then I get AB is equal to AM plus DM. And we just used the substitution property. Okay, so for this next one, we're given that angle AEB is a complement of angle BEC, and we're trying to prove that the measurement of AED is equal to 90 degrees. So we're going from congruence statements to measurement statements, right, or equality statements, as I like to put it. All right, so we're given that angle AEB is a complement of BEC. That basically means what? It means that they add up to 90 degrees, but we actually have to state that, right? So by the definition of complementary angles, then we can state that if AEB is a complement of BEC, then the measurement of AEB plus the measurement of BEC is equal to 90 degrees, okay? And then from there, we want to state that AEB plus BEC gives us AEC, okay? So basically what we just used here was the angle addition postulate. All right, then they stated that the measurement of AEC is equal to 90 degrees. So basically, in line 2, we stated that those two measurements equal 90 degrees. In statement 3, we said that those two also add up to give us AEC. So we can then conclude that measurement of AEC is equal to 90 degrees. We just used the transitive property of angle congruence. Okay, where's the pen? Okay, so the transitive property of angle congruence. Now, if you wrote substitution, because technically you're also substituting, that would also be okay. There's more than one way to write this. All right, so then next, they said measurement of AEC plus the measurement of AEC is equal to 180 degrees. That is by the definition of supplementary angles. So we know that these two are going to add up to 90 degrees, to 180 degrees. All right, so then from there, by using the substitution property, we could state that the measurement of AED plus 90 degrees equals 180 degrees. So the reason I did that was I know that the measurement of AEC equals 90 degrees, so I went ahead and plugged that in for the measurement of AEC, right? So then I just used the substitution property of equality. All right, from there, I can then state that the measurement of AED equals 90 degrees. So what I basically did was I subtracted 90 degrees on both sides to give me that the measurement of AED is equal to 90 degrees. So what I just used here was the subtraction property. Subtraction property of equality. All right, so this next part states in exercise 3 and 4, name the property that the statement illustrates. If angle RST is congruent to angle TSU and angle TSU is congruent to angle VWX, then angle RST is congruent to angle VWX. Basically, what we're using here is the transitive property of congruence. I'm just going to write transitive property of congruence. All right. If line segment GH is congruent to line segment JK, then line segment JK is congruent to line segment GH. So basically what we're using here is the symmetric property. Of segment congruence. If you wanted to, you could also write symmetric POC, and I would know what you're talking about. All right, so this next one, it says write a 2-column proof based off of the given information. I actually want you guys to pause this video, and I want you to try it yourself. And then once you're done, I want you to unpause it and compare what I got with what you got. Okay, so at this point, everybody should have attempted this problem. Now, before we start, I do want to let you know that there are several ways that you could write a proof. There's not just one way. So, if yours is a little bit different, that's okay. But I'm just going to give you one example of how you can write this and just compare it to what you have. Okay, so obviously everyone does have to start with the given. So in this case, your first statement is going to be M is the midpoint of RT. And the reason for that is that, well, it's given. For the second part, we know that RM is congruent to MT. Now, why can we state that? The reason we can state that is because of the definition of a midpoint. Now, for the third part, so we know that these two are congruent because the definition of the midpoint, but now I need to actually look at this side, right? So we know that RM, I could break that up, and I could say RM is equal to, the measurement of RM is equal to RS plus SM. So this is just the segment addition postulate. All right, for the fourth part, we know that MT is congruent to RM, okay? We know that because of the symmetric property, right? So from the symmetric property. In statement 2, we said that RM is congruent to MT. In statement 4, we're saying that MT is congruent to RM. So we flipped them, and that's just the symmetric property. All right. Next, if you notice in the proof, it's giving us the equality statement. But as of right now, I only have a congruence statement for MT and RM. So I need to change that, and I need to make that MT is equal to RM. So now we're dealing with the actual measurements themselves. So what I basically just used was the definition of congruent segments. All right. So in step 3, we stated that RM is equal to RS plus SM, and in step 5, we said that MT is equal to RM, right? So now all I have to do is substitute RS plus SM for RM. So I get MT is equal to RS plus SM, and basically I just used the substitution property. Now, if you don't include, again, I think I mentioned this earlier, but if you're not including the property of segment congruence versus the property of angle congruence, I'm not going to count off for that because essentially it is the same thing. You're still substituting. I hope that this video helped. If you have any questions, feel free to ask me. You can either email me or you can ask me tomorrow or whenever I get back. And if you had a different proof and you wanted to check, you could check with me when I get back and I can let you know if it was correct or not. But other than that, you guys have a Big Ideas assignment that I want you working on, as well as a Schoology assignment, so please make sure that you do that. Alright, have a good day.